Conjugate. Today I am going to discuss one more problem on touching spheres. So coming to the problem, show that the spheres x square plus y square plus z square is equal to 64 and x square plus y square plus z square minus 12x plus 4y minus 6z plus 48 is equal to 0. Show that the two spheres touch internally and find the point of contact. So in our previous class we discussed about the two spheres touch each other externally. So today I am going to discuss the two spheres touch each other internally. Okay. So here we are having a condition that so whenever C1 C2 is equal to modulus of R1 minus R2, then we say that the two spheres touch each other internally. Okay. So it means once again we have to find the centers and radius of the two spheres. So first of all we have to write the given spheres. So the given spheres are x square plus y square plus z square minus 64 is equal to 0. So this is the first one, and x square plus y square plus z square minus 12x plus 4y minus 6z plus 48 is equal to 0. So this is the second one. So now we have to find the centers for both the spheres as well as radius for both the spheres. So now I am finding center for the first sphere, that is C1. So in the first equation we are not having x term, y term and z term. So the center of the sphere is origin. It means 0, 0, 0. Okay. So whereas coming to the radius R1 is nothing but square root of, we have to write u square plus v square plus w square minus d. So we get 0 plus 0 plus 0 minus d. So since we are having minus 64, if you write another minus, we get plus 64. It means we get root 64. Root 64 is nothing but 8. So this is C1 and C2, center and radius of first sphere. So whereas coming to the second sphere, center C2 is equal to. So since we are having the coefficient of x as minus 12, we have to write the half of the coefficient, and also we have to change the sign of the coefficient. It means we have to write 6. Okay. And from the y coefficient we have to write minus 2. Okay. And from the z coefficient we have to write 3. So don't forget to change the sign also. So whenever we are having the coefficient of z as 6, we have to write half of the coefficient, and at the same time we have to change the sign of the coefficient. Since we are having minus, so we have to write plus while writing center. Okay. Right. This is center C2, and radius R2 is equal to square root of u square plus v square. It means 36 plus 4 plus 9 minus 48. Since we are having 48 as a constant in the second sphere, so that we have to write minus 48. So 40 plus 9, 49 minus 48, which is equal to root 1. Root 1 is nothing but 1. So R2 is 1. So after finding C1, C2 and R1, R2, so now we have to find the distance between C1 and C2. So C1, C2 is equal to, so the distance between 2 points can be written as square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So treat C1 as x1, y1, z1 and C2 as x2, y2, z2. So then we get 6 minus 0 means 6 whole square. Of course, we have to write one more point. This is plus Z2 minus Z1 whole square, right? Plus minus 2 minus 0, it means minus 2 whole square plus 3 minus 0, that is 3 square. So we get this is equal to square root of 36 plus 4 plus 9, 40 plus 9. It means we get root 49. Root 49 is nothing but 7. So therefore, the distance between C1 and C2 is 7. So if you want to say the two spheres touch each other internally, so then the condition what we have to satisfy is, so the distance between C1 and C2 is equal to the modulus of R1 minus R2. Okay. So therefore, here we get C1 C2 is equal to 7. Now I am considering modulus of R1 minus R2. So this is equal to modulus of R1 is 8 minus R2 is 1. So we get modulus of 7. So modulus of 7 is nothing but 7. So therefore, so we say that C1 C2 is equal to modulus of R1 minus R2. So whenever these conditions satisfied, so we say that the two spheres touch each other internally. Okay, so we are having just 2 points. One is touch each other externally, and the second one is touch each other internally. So whenever C1 C2 is equal to R1 plus R2, so then we say that the two spheres touch each other externally. And whenever C1 C2 is equal to modulus of R1 minus R2, then we say that the two spheres touch each other internally. So it means the spheres are in this way. Here, the first one is big sphere and the second one is small sphere. Here, the two spheres touch each other internally. Okay, whenever the two spheres touch each other internally, clearly we are having a point of contact. Okay, it means this is the P. We have to treat that particular point of contact as P, and now we have to find that particular point of contact. In our previous class, we discussed that point of contact. Whenever the two spheres touch each other externally, then the point of contact can be divides C1 C2 in the ratio R1 to R2 internally. Whereas coming to the two spheres touch each other internally, so this P divides C1 C2 in the ratio R1 to R2 externally. Why? Because clearly the point P lies outside the, means on the line. Okay, so that we say that P divides C1 C2 in the ratio R1 to R2 externally. Okay, so now we have to write the formula for externally. So I am writing that P be a point of contact. Let P be a point of contact, and P divides C1 C2 in the ratio R1 to R2 externally. Okay, so now the formula for P is equal to, so whenever it is internally, we have to write mx2 plus nx1. So since it is externally, we have to write mx2 minus nx1 by m minus n, comma m by 2 minus n by 1 by m minus n, comma mz2 minus nz1 by m minus n. So this is the formula to find the point of contact externally. Okay, right. So here we have to write the points. So one is center 1. Since we are having center 1 as 0, 0, 0, and the center 2 as 6, minus 2, 3. 6, minus 2, 3. And the ratio R1 is to R2 is, so here R1 is 8, R1 is 8 and R2 is 1. R1 is 8 and R2 is 1. So treat this as M and N. M and N, and this is X1, Y1, Z1, and this is x2, y2, z2. So we have to substitute these values in the formula. So this is rough work for understanding. Okay, right. So now I am substituting the values. mx2, m is 8, x2 is 6, 8 6 are 48, minus nx1, n is 1 and x1 is 0, so that we get 0 by m minus n, means 8 minus 1 is 7, comma m by 2, 8 into minus 2, that is minus 16. Next, minus n by 1, y1 is 0, so that we get minus 0 by m minus n is once again 7. mz2, 8 into 3, 24, minus nz1, that is 0, by once again m minus n, that is 7. So finally we get 48 by 7, comma, minus 16 by 7, comma, 24 by 7. So this is the point of contact. So when two spheres touch each other internally. Okay. Hello students. So moving on to the next concept, that is plane of contact. Here the equation of the plane of contact of the plane of contact of the external points B x1 comma y1 comma z1 with respect to the sphere s is equal to 0 is s1 is equal to 0. So here, so this is s1 is equal to 0 is nothing but that is the equation of the plane of contact of the external point with respect to the given sphere. Okay, if you want to find a plane of contact at the external point B with respect to the sphere, so we have to write the formula s1 is equal to 0. Okay, so I am going to do one problem on this particular node point. So coming to the problem, find the plane of contact, find the plane of contact of the points 2 comma minus 1 comma 1 with respect to the sphere, 2 into x square plus y square plus z square minus 10x plus 6y plus 4z plus 5 is equal to 0. So here we are having a sphere equation together with a point. Now we have to find the plane of contact, and the formula for the plane of contact is nothing but s1 is equal to 0. So that we have to write the formula s1 is equal to 0 and simplify, then we get the plane of contact. Okay, right. Coming to the solution, given sphere equation is so 2 into x square plus y square plus z square minus 10x plus 6y plus 4z plus 5 is equal to 0. And the point is 2 comma minus 1 comma 1. Okay, so now the equation of plane of contact. The equation of the plane of contact is, I'm simply writing it as S1 is equal to 0. So treat the given sphere as S is equal to 0. So the formula to find the equation of the plane of contact is S1 is equal to 0. So here we have to write S1 by seeing the sphere. Okay. So I am writing that. So 2 into, so whenever we are having x square, we have to write x into x1. So in place of 1x, we have to write x1. Similarly, we have to write y square as y into y, and in 1y, we have to write y1. Similarly, z square can be written as z into z1. Okay. And coming to the coefficient of x, we have to write minus 10x as minus 5 into x plus x. Minus 5 into x plus x is nothing but minus 10x. So in place of 1x, we have to write x1. Similarly, coming to the coefficient of y, here also we have to write half of the coefficient of y, that is 6y can be written as, so 3 into y plus y. So 3 into y plus y, and in one place of y, we have to write y1. And similarly, 4z can be written as 2 into z plus z1. Okay, plus 5 is equal to 0. So this is nothing but S1. Okay, I am writing the S1 with the help of S. Okay, so in place of x1, y1, z1, now we have to substitute the given point. So now substitute 2 comma minus 1 comma 1 in the above equation. We get 2 into x1 is 2 plus y into y1 is minus 1 plus z into z1 is 1 minus 5 into x plus x1 is 2 plus 3 into y plus y1 is minus 1 plus 2 into z plus z1 is 1 plus 5 is equal to 0. So finally we get 2 into 2x minus 5 plus z minus 5x minus 10 plus 3y minus 3 plus 2z plus 2 plus 5 is equal to 0. And finally we get 4x minus 2y plus 2z minus 5x minus 10 plus 3y minus 3 plus 2z plus 2 plus 5 is equal to 0. So now first we have to write the coefficient of x, I mean x terms. Here we are having 4x minus 5x, that is minus x. And after that we are having y terms minus 2y plus 3y, that is plus y. Coming to the z terms, 2z plus 2z, that is 4z. And coming to the constants, here we are having minus 10 minus 3 minus 13. Minus 13 plus 5 is minus 8. Minus 8. Minus 13 plus 7 is minus 6. We get minus 6 is equal to 0. We cancel minus from this equation, we get x minus 5 minus 4z plus 6 is equal to 0. So this is the plane of contact. Plane of contact with respect to the given sphere at the point 2 comma minus 1 comma 1. Okay, right. So coming to the next definition, that is polar plane. Polar plane and pole. Let S is equal to 0 be a sphere. Capital B be a given point. Be a given point. Full stop. The locus of the points such that the plane of contact of each point with respect to the sphere s is equal to 0 passes through the point, passes through B. So B is the given point, passes through the B, is a plane, and it is called the polar plane. And it is called the polar plane of B with respect to the sphere s is equal to 0. Okay, here polar plane is nothing but it is the locus of the points such that the plane of contact of each point with respect to the sphere. So each and every point such that the plane of contact with respect to the sphere s is equal to 0 passes through the point capital B. Then we get a plane and it is called the polar plane. Okay, with respect to the sphere s is equal to 0 and the point B is called, and the point we call the point B is called the pole of the polar plane. It's called the pole of the polar plane. Okay, so once again a polar plane is nothing but, once again if you want to find the plane, polar plane with respect to the sphere s is equal to 0 at the point, the formula is nothing but s1 is equal to 0. Okay, so I'm writing that. So note point, the equation of the polar plane, the equation of the polar plane of the point x1 comma y1 comma z1 with respect to the sphere s is equal to 0 is s1 is equal to 0. This is clear. Okay, so coming to the next definition, that is conjugate points. Conjugate points. The 2 points capital A and capital B are said to be conjugate points with respect to the sphere s is equal to 0 if the polar plane of A passes through B. So it means if you want to say 2 points are conjugate points, so with the help of 1 point we have to find the polar plane. Okay, after finding the polar plane, the second point should satisfy the polar plane equation. So if this happens, then we say that those 2 points are conjugate points. Okay, so coming to the next definition, that is conjugate planes. So conjugate planes. 2 planes phi 1 and phi 2 are said to be conjugate planes with respect to the sphere s is equal to 0 if the pole of phi 1 lies on phi 2. It means first of all we have to find the pole for the first plane, and if the pole of the first plane lies on the second plane, then we say that the two planes are conjugate planes. Okay. Coming to the last point, that is conjugate lines. So conjugate lines, two lines L1 and L2 are said to be conjugate lines with respect to the sphere s is equal to 0 if the polar plane of every point on L1 with respect to the sphere s is equal to 0 passes through L2. Okay. So whenever the polar plane of every point on L1 passes through L2, then we say that the two lines are conjugate lines. So while doing problems, I will explain you in detail. Okay, these are the very, very important definitions regarding the plane of contact, of course, polar plane, pole, conjugate points, conjugate planes, and conjugate lines. In the next class, we will do problems on these concepts, on these definitions. Okay, thank you.